Welcome back to another deep dive. Today, we're zooming in on something I know our facility planners and electrical engineers deal with constantly. We're talking about a piece of infrastructure that honestly gets totally taken for granted. To a lot of folks, a cable tray is, well, it's just a metal basket hanging from the ceiling, right? But in this explainer, we're going to completely flip that script. We're looking at cable trays not as passive hardware, but as a dynamic, absolutely critical backbone that can literally make or break your entire electrical network.
Okay, let's dive right into this, because what we're looking at here hits on the core fears of any engineer. Every single choice you make about a tray doesn't just dictate where cables sit. It directly impacts your system's total ampacity. It dictates how fast your team can access things during a critical outage, and it takes a massive bite out of your ongoing maintenance budget. A tiny miscalculation here? There's no way around it. It doesn't just look sloppy, it can trigger catastrophic system failures or completely blow your project budget out of the water. So here's our game plan for today's explainer. We're going to quickly break down the 4 core functions of a tray, and then really dig into analyzing the differences between industrial and commercial selection. After that, we'll expose the hidden costs of heat and derating, walk through a zone-by-zone cheat sheet, check out how busways and trays work together, and finally wrap up with international standards and ZINMA systems. Lots to cover.
All right, let's get right into the foundational stuff. What these trays are actually doing up there.
I really want to establish a baseline here because a cable tray is juggling multiple highly demanding jobs at the exact same time. In fact, 4 is the magic number to keep in the back of your mind as we go through this. A tray isn't just chilling out, it is actively performing 4 distinct, critical functions all at once.
Think about it. First, it's physically holding up the sheer weight of the cables. Second, it dictates the entire routing path of your power network. Third, it provides essential physical armor against the environment. And fourth, and this is the absolute kicker, it actively influences the operating temperature of those very cables. The really tricky part for us engineers is that every single design choice you make alters at least 2 of these functions simultaneously. So you're constantly walking this tightrope trying to balance it all out.
Now, let's pivot to what I think is the most crucial part of this whole discussion: how we handle wildly different environments.
This brilliantly illustrates our main focus today, analyzing the industrial and commercial application differences. Because let's be real, treating a commercial shopping mall the exact same way you treat a heavy industrial plant, that is a fast track to disaster. Over on the left, we've got our industrial setups. We're talking rugged, dirty environments where you desperately need immediate physical access for maintenance and maximum heat dissipation. But jump over to the right. Commercial applications. These are your clean environments, usually stuffed up behind a drop ceiling, where visual aesthetics and totally shielding the cables are your top priorities. It's like night and day.
And because of those completely opposing demands, we arrive at this golden rule. The same tray type rarely fits both. Actually, scratch that. It almost never fits both. If you take a lazy, one-size-fits-all approach to your routing, you are 100% guaranteeing a compromised system. You're going to end up with either an industrial plant that is chronically overheating or a commercial building that is a total nightmare for your maintenance crew to service. Speaking of overheating, let's talk about the real silent killer in electrical design.
Temperature. Heat is the ultimate stealth enemy, and I want to show you this dangerous chain reaction. Let's say you decide to swap out a highly ventilated open ladder tray for a covered, solid bottom one, just because you think, hey, I want more physical protection. Seems innocent enough, right? Nope. Step 2 kicks in immediately. Your cable temperature artificially spikes because all that heat is now trapped inside a metal box, which forces step 3, mandatory ampacity derating. You have literally just choked off your own power capacity simply by putting a lid on your tray.
And we are not talking about a tiny little fluctuation here. That seemingly innocent choice can cause your operating temps to spike by 5 to 15 degrees Celsius. To put that into perspective for our electrical engineers out there, that is a devastating margin. That much excess heat is going to rapidly bake your insulation over time and severely handicap how much power you can safely push through your facility.
Now, what's really interesting and honestly kind of painful about this is the concept of ampacity derating. That 5 to 15 degree penalty completely wrecks your design because derating is the mandatory reduction in your cable's current carrying capacity. You have to do it to prevent the insulation from melting due to that trapped ambient heat. So if you trap heat with the wrong tray, the electrical codes legally force you to run less power through your extremely expensive cables just to avoid a fire. You are paying big bucks for system capacity you aren't even allowed to use. It's wild.
So the obvious question is, how do we dodge this derating trap entirely? Let's look at a concrete solution.
I highly recommend you pause and really absorb this matrix. Think of this as your ultimate zone-by-zone cheat sheet for routing infrastructure. If you're looking at heavy industrial zones like pipe racks or MCC rooms, your logic absolutely must prioritize open ladder trays so you get maximum airflow. But when you cross over into commercial spaces, offices, malls, hospitals, your logic has to shift towards solid or ventilated trough trays because now you care about shielding and aesthetics. And then you've got data centers. Those are a crazy hybrid beast requiring ultra-precise cable management and massive weight capacity. Nailing this specific logic is how you build a system that actually works in the real world, not just on a CAD drawing.
But what happens when even the perfect tray system just isn't cutting it? Let's zoom out a bit.
We've got to look past traditional trays and ask a really critical pivot question. When do you just abandon trays altogether and switch to busways? Because look, sometimes trying to wrestle hundreds of ultra-thick cables through a standard tray is it's not the smart move, and it's definitely not efficient.
The magic really happens when you create synergy between the two. This is how you solve those massive routing headaches. You deploy high-capacity busways to replace your heaviest tray routes. Think of them as your main power arteries. Then you align that busway with lighter, flexible cable trays branching off of it. It's a game changer. It massively shrinks your physical space requirements, cuts your installation complexity way down, and seriously optimizes the thermal performance of the whole building.
Of course, pulling off this kind of advanced engineering requires hardware you can actually trust.
And that brings us to Shanghai Sima. They provide a genuinely comprehensive portfolio for this dual environment engineering. They aren't just stamping out trays, they're engineering the whole ecosystem. We're talking advanced cable trays, the busways we just mentioned, vital seismic bracing, and intelligent cable management, the whole shebang. End-to-end solutions perfectly tailored for all those specific zones we just mapped out. Whether it's a hyperscale data center, a rail transit hub, a gritty industrial plant, or a pristine commercial tower.
So, the crucial point here is compliance. When you're engineering critical infrastructure, compliance is absolutely non-negotiable. Specifying ZINMA guarantees your setup hits the strictest global standards. We're talking IEC 61537, NEMA VE1, BSEN 500085, and GB 31251. It gives everyone, from the facility owner to the lead engineer, total peace of mind that the design is globally recognized for safety, durability, and absolute peak performance.
Which brings us to one final, slightly provocative thought to leave you with as we wrap up. Is your current cable routing quietly costing you ampacity and draining your maintenance budget as we speak? Take this framework you just learned in today's explainer, take a walk through your facility, and just look up. The answer might actually shock you. Thanks so much for joining me, and I'll catch you on the next deep dive.